Welcome, scholars. This is our lesson on functions and function notation. Here's our objective. I can determine if a relation is a function and can evaluate a function using function notation. And you're like, Mr. Gibbs, what the heck is a function? I know, and it's okay. This is one of the things that we learn in pre-algebra and you get introduced to. It's just going to come at you really quick here, but we're going to pause a little bit and make sure that you understand before we move on, okay? So we're going to figure out what a function is today. We're going to learn some other words like domain and range and yada yada yada. And we're going to learn what function notation is. So just stick with me. If you get a little bit lost at any time, pause and re-listen or write down a question that you want to ask me and we'll definitely address it. Okay, some terminology. And I typed this up because I thought it would be easier for you to write down. But so this is what you have. You have ordered pair, and you're going to write this down. An ordered pair is always written as some x value, comma, some y value with parentheses. This is always how we write it. So for instance, we might write 0.1, comma 2. That means I have an x value and a y value. It's always alphabetical, always an x and then a y. A relation. A relation is a relationship between sets of values. This 1 and this 2 go together. They're a relation because they describe a point, okay? So basically any point you make on the coordinate plane creates a relation. And if you have a set of points, any point is called an ordered pair. Any set of points, if I have multiple points on the coordinate plane or a line or a curve or a circle, those are all called relations. Now the question is your relation also a function? And we're going to talk about that in a second. Another important word, domain. We use domain to describe the set of all the x values, meaning if I've got a whole bunch of points or a line, where does it live in reference to our x-axis, our x values? So I know that my domain here at least is 1. Maybe if there's other points, it's more than 1. But the domain describes your set of x values. The range then describes all of your y values. Now we're looking at the y-axis. In this case, 2 would have to be part of our range. I'm going to show you some examples to give you a better idea of domain and range. Finally, a function is a special type of relationship in which, you're writing this down, each input has only one output. Each input has only one output. If you need to pause to get all this stuff down, please do. A function is a special type of relation in which each input has only one output. A one-to-one function, this isn't as important to me, but a function is a function where in the range corresponds exactly to one element in the domain, meaning that the range doesn't repeat either. The y values don't repeat either. For instance, a line on a coordinate plane is always a one-to-one function unless it's a vertical line, okay? So let's look at these domain and range statements here and see which one is a function and which one is not. And I'm going to help you with that because I know that these little bubble ideas are new to you. So these are all of our x values and these are all of our y values. Since there's a line from here to here, it means that these two things go together. Another way of saying that is that I have a point -3, 1. I have an x value that's -3. I have a y value that's 1. This is just a different way of representing that. Why do we like to represent that? Because we see when things converge in this way. Okay, but this is obviously a one-to-one function because every x has its own y. So we are going to call this a function. Now, notice that these two numbers go to the same number in the range. So we've got a point like -1, 5. We've also got a point 4, 5. Well, this means that this is not a one-to-one function. You can write one-to-one down here if you want to. But I'm really concerned that you know functions. But the question is, does each input have exactly one output? Well, -1 has only one output. It's 5. 4 has only one output. It happens to also be 5. But I'm okay with that because neither of these have multiple outputs, multiple lines going away from them. So we are going to call this a function as well. Now here's when we have a non-function. -3 has two different outputs. It has a 0 output. It also has 6 as an output. So this is not a function. Not a function. Because -3 has multiple different outputs. It is this and this alone that is the problem. I don't care about this. Okay. We're going to look at a graph now. It asks us to state the relation shown in the graph, then list the domain and the range. Is it a function? Okay. The relation here are, I'm just going to say, is all the points. When you put the points together, it's a relation, okay? Well, what's the domain? Well, domain is the set of all x values. So in this case, since there are just points, they just happen, and then if you move, they go away, I'm just going to write down all the x values going from biggest to smallest. So I'm going to say my domain is -4 and -1 and 0 and 2 and 3. I just took all of my x values, moving from left to right, from biggest to smallest. Now my range is all my y values. So I'm going to move from smallest to biggest because this is negative land on my y-axis. This is positive land. So from smallest to biggest, I'm going to start. My smallest looks like it's -4. And then -3. And then -2. And then, oh, looks like we have 3. It occurs twice, but who cares? 3 is part of my range. Okay, and I'm very terrible at making these brackets. Maybe you can make them look nicer, but I'm using this special bracket to say that this is encompassing this domain. Is this a function? Well, all I care about is my domain. And as long as my domain didn't repeat at any point, I'm okay. Well, this -4 didn't repeat. This -1, it didn't repeat. This 0, it did not repeat. This 2, it didn't repeat. This 3 did not repeat. So is it a function? Yes. Okay. You try. So pause it, try, see what you fill out compared to mine. I'm going to say all the points again are the relation. Okay, domain, make sure you try this on your own before you ask me. Okay, well, it looks like I've got a -4. Looks like I've got a -2. And a 2 and a 2. Uh-oh. I'm going to circle this because I think this is a problem, okay, when I think about functions. And going from smallest to biggest, I've got -3, -2, 1, and 3. Okay, is it a function? Well, this 2 can't repeat. Notice that there's this x value, there's a 2 here and a 2 here. No, this is not a function. Turning over. A easier way to figure out what, when I'm given a graph, if it's a function or not a function, is doing something called a vertical line test. And let's read. When given a function of a relation, one can perform a vertical line test to determine if the relationship is a function. So this test, if I have a graph, will always tell me whether a relation is a function or not. So here's what to do. If you drop in vertical lines and they do not intersect the graph in more than one point, then it is a function, okay? If they do intersect in more than one point, then it is not a function. Okay, so we said we need to do a vertical line. You might want to do multiple vertical lines to test, but if I drop a vertical line, it should not touch the other line more than, or it should not touch the graph more than once. And it looks like this touched 1, 2 times. If it touches more than once, it is not a function. So we are going to write not a function. Okay, let's try this one. If I draw a vertical line there, it only touches once. Now we might want to test multiple places. So far I think it's a function. What if I draw a vertical line here? Well, it only touches once. What if I draw a vertical line up here? Oh, it's a bad vertical line. It only touches once. No matter where I draw a vertical line on this, it is always going to be a function. Hint, linear things are functions. Okay, so this is a function, because a vertical line only ever touches it once. Basically, this is telling us that an x value does not repeat, right? There's only one x value here. There's only one x value here. But there's 2 x values right here at 2. There's 2 x values here, or 2 y values. Let me say that differently. Our x value has 2 different outputs, right? Sorry everyone, our input, our x value, has 2 different outputs, 2 different y's. That just does not work. That makes it not a function. Okay, let's try again. I draw a vertical line. It only touches once. It only touches once. It only touches once. This is a function. Ooh, but no matter where I draw a vertical line here, it's gonna not a function. So if you can draw a vertical line anywhere on the graph and it touches twice or more than twice, it's not gonna be a function, okay? It's gotta be true everywhere. Okay, let's look at this graph. We already know it's a function, it's linear. I can use the vertical line test. And we can write this line as y equals 2x plus 1. We know it's a function. We can see that from the graph. This relationship also can be written with function notation. We're going to replace y with this idea that is f of x. Okay, we write this as f of x. Okay, that's how we say this. A function of this independent variable. This is basically just saying whatever I'm going to get out, its independent variable is x. Our independent variable is x, and we're going to get out y. We're going to get out our function. So we're saying this function This is a function of whatever x is. So depending on what x is, I'm going to get a different value out right here. It's fancy, but it's something we're going to use a lot this year, so we need to know how it works. We're going to finish up here today to learn how it works is we're just going to say, or we're just going to try a few. Now, I want you to know that this idea, this is saying that x is -3, right? I'm plugging in, instead of writing an x here, I'm plugging in -3, okay? Instead of, sorry, you can't see that. I'm putting in -3 instead of writing an x here. So that means anytime I see an x, now I've got to change that to a -3. Okay, this is the same as like in 7th grade, 6th grade when your teacher said, x equals -3, friends. What is the value of the problem? Do some basic math. And you're saying, okay, I can do basic math. So we're saying that if I've got f of -3, and this function is represented by this idea here, then anytime I see x, I'm going to put a -3 there instead. And I need to put my +2. So notice the only thing I changed about this idea and this idea is instead of writing x, I wrote -3. Now I wrote this in parentheses because when I square this, this is going to be -3 times -3. And if I didn't have the parentheses there, I'd be saying something totally different. So please put the parentheses there. Now you're just evaluating. This is equal f of -3 equals, well, -3 times -3 is 9, plus 2 is 11. Same thing. G of 2.8 equals, well, that's a mess, isn't it? 0.5 times 2.8 squared minus 5 times 2.8 plus 3.5. Woo! I'm invading my space here. Okay, so notice the only thing I changed going from here to here is instead of writing x wherever I saw it, I wrote 2.8. I wrote 2.8. I wrote 2.8. Okay. Now, you can finish evaluating by just plugging this into a calculator and finishing getting your answer. I'm not even going to worry about that right now, okay, because I want to move on. Okay. F of 3z equals, well, instead of writing x, what am I writing? I'm writing what's here, 3z. So instead of writing x, I'm writing 3z. It's still squared, and it's still plus 2. Go back and notice the only difference here is that instead of writing x, I wrote 3z. We can simplify this a little bit. 3 squared is 9, and z squared is z squared. And this is plus 2. These are not like terms, so we can't simplify any more. Okay, you try. So we've got, go ahead and pause and try on your own, but this equals -2 to the third minus 3. -2 times -2 times -2 is -8 minus 3, which equals -11. I'm just going to write this out like I did the one above. This equals 0.3 times 1.6 squared minus 3 times 1.6 minus 2.7. You can put that into a calculator if you want to, but I'm not going to. Finally, this, wherever I see, hey, did you notice, by the way, and I don't think I said it very well up here, Notice this h told us that we're using this h equation. This f told us we're using this f equation, okay? So we're back to the f equation. Wherever I see x, I'm putting 2t instead. So instead of x to the third, I've got 2t all to the third minus 3. Okay, 2 times 2 times 2 is 8. T to the third is t to the third minus 3. Okay, you need to let me know if you have any questions, or else you should know what to work on next. Thank you.